You already know at this point that AMD is working on an AI-based upscaling technology called FSR 4. And no, in this video, I'm not going to go through the same Tom's Hardware article and re-quote what Jack Huynh said, because there is already a lot of video doing just that. In this video, I'm going to teach you guys something. And if you clicked on this video, then I dare you not to close this video. Just don't. I have spent a whole day and night reading for this video. If I studied this hard for my ML exam when I was back in uni, I would have gotten 90% on that paper rather than getting stuck at 72. Now, before I start using all the sensational words like AI, ML, Nvidia versus AMD, let's learn what image upscaling is. It is a technique used for increasing the resolution of an image or a video. Now, here increasing the resolution doesn't mean increasing the dimensions. We generate and add new pixel data in a frame from already existing pixel data. Now here, pixel data isn't a color per se, but numerical values of those colors. For example, if we want to upscale a 1080p video to a 4K video, then we have to generate per frame over 6.2 million new pixel data. Now the number might seem very large, but thanks to AI and other computational improvement, it is possible. Now, upscaling can be done in various different ways. Traditional interpolation method, where we take the nearest pixel data to generate the missing pixel data, which include nearest neighbor interpolation, bicubic interpolation, and bilinear interpolation. Then there is filter-based techniques, where we use mathematical filters to determine the contribution of nearest pixel while upscaling an image. For example, AMD used an advanced version of Lanchon's resampling for FSR1. There are also other types of techniques like frequency-based upscaling, where we convert the video data into a frequency data. But all of these are example of spatial upscaling. These are good where there isn't a lot of movement, because they generally take data from a single frame and work on a single frame. But games are nothing but movement. So for games, we need temporal upscaling, where we use pixel data from multiple frames. Now, it can be done with the help of AI or without the help of AI. For example, Nvidia and Intel both used AI for their temporal and spatial upscaling. But on the other hand, AMD still now don't use AI for their temporal and spatial upscaling. But what does that mean? AI, because a lot of people don't fully understand the term. According to father of AI, John McCarthy, the science and engineering of making intelligent machines, especially intelligent programs. And from the beginning of AI, 1950s, the philosophy of AI was simple. Can a machine think and behave like humans do? But to think and behave like human, machines needs to learn like human. And that's where in 1980s we got machine learning algorithms, and they can be simply summed up into an AI system that can learn from historical data. And regression, classification, SVM, KNN, knife biases, decision tree, random forest, all are good examples of that, learning from historical data. But they are not good at learning from their mistakes. So around the time of 2010, we got the concept of deep learning or neural networks, machine learning models that can mimic human brain function. And now it has evolved into generative AI, deep learning models that can generate original content. But we need to focus on deep learning or neural networks, because when someone is talking about that AMD is going to use AI for their FSR4, essentially they are saying that AMD will use some sort of neural network model like Intel and Nvidia. Although we don't know what kind of model Intel uses for their upscaling technology, we just know that it is a deep learning model with attention mechanism. But we know what kind of algorithm or what kind of model Nvidia uses for their upscaling. CNN or convolutional neural networks. Generally what this model does, it takes pairs of image, one low resolution as an input and another higher resolution image as ground truth. Then during training, the model learns how to upscale an higher resolution image from the lower resolution image by minimizing the differences between the now generated high resolution image as output and previously given high resolution image as a ground truth. So the model can better understand and predict the important parts of an image. DLSS also uses temporal data to maintain the consistency between frames, reducing flickers and improving motion clarity. Once the model is trained, it can be used in real time with less computational overhead for upscaling. So would AMD use this type of model for FSR4? They could, or they could use other models like GAN, Generative Adversarial Networks. This type of model is very interesting because this is almost a hybrid model. They generally made up with two CNN networks. One is a generator that generates higher resolution image from lower resolution image, and another is a discriminator which is there to find the mistakes and distinguish the differences between the generated image from the generator and the original higher resolution image that the discriminator always have. But the most interesting part is how these models are trained. They are generally trained or mostly trained in adversarial nature. That means the generator will always try to fool the discriminator, and the discriminator will always try to find the mistakes that the generator made. And there are models like this in use. For an example, SRGN, Super Resolution Generative Adversarial Network, which creates highly detailed image. However, this type of model has one big problem. If the model is not trained properly and carefully, the model will collapse, where the generator will produce limited variants of images and also can introduce artifacts. But neither CNN and GAN have internal memory per se, so they cannot remember what's the output is and take that as an input by backpropagating and updating the variants. But RNN can, or recurrent neural networks can, because this is a type of feedback neural network. The model can remember information from previous frames, which makes it useful for analyzing each frame of a video and how it relates to previous and subsequent frames. And it also ensures temporal coherence, avoiding jitters and flickers while creating better images with each subsequent pass. This makes it a great option for video upscaling, where temporal stability is important, or in other words, video game. But it is very computationally expensive, especially if you are trying to run it in real time, unless AMD builds a separate architecture to accelerate this type of models, which I don't think is happening. And are there other techniques on neural networks? Yes, like autoencoders, transformers, U-Net or capsule network, or a hybrid network using some part of one and some part of another, maintaining the visual clarity while being computationally less expensive. So, what kind of AI will AMD use? At this point, I don't know. But if they combine what they have learned from FSR1 to FSR3 and an AI model like CNN, they could build a really robust and great looking model which could compete with Nvidia and can even beat outright Intel's Xess. And why I am saying that it could compete with Nvidia? Well, DLSS had the time to mature itself. With each subsequent release, DLSS improved itself to a point. Yes, the DLSS 3.5 was a frame generation update, which is another interesting topic, and that's also is another loophole itself. So if you want that video, let me know in the comment section. But FSR4 is going to be AMD's first attempt when it comes to AI upscaling. Now, if you made this far of the video, let me know in the comment section. I need to thank you guys personally, because this wasn't really about FSR4. I just wanted to teach you guys like what neural networks are, although I haven't. I just gave you guys a very brief summary. I didn't even told you guys how a neural network works. It's super interesting. There are a bunch of things to learn about neural networks, deep learning, and generative AI. It's so surreal and it's very interesting. I gush, like I'm literally blushing talking about that because I love that subject. I just read only ML on third semester and forgot about that other papers exist, and I also need to study those papers so I can pass my semester, but somehow I did. And that's the reason I'm not really great with data structures, but that's another topic for another day. But yeah, if you made this far, leave a like. If you haven't made this far but you're still watching, I don't know how, leave a dislike. And if you want to watch more videos from us, check out this video right here. And if you want to subscribe, I'll do it by here. And there's Akash, and I'll see you guys in the next time. Peace.